Oh, hello. Welcome to another video of by example, and this is for straight lines. So this should help you with the upcoming test. I'm gonna go straight into it. So we've got this triangle A, B, C, and it has vertices or points A, B, whoops, and C. So these are the three coordinates we'll be playing with. Um, Straight away it's asking for the midpoint of B to C, so from there to there. All I'm going to do is just, if I work over here, add up all my x coordinates, so 4 plus 2, and then divide by 2, so that'll give me 6. My x coordinates 3 then, and likewise I'm going to add up my y coordinates, so 1 plus minus 5 gives me minus 4, divided by 2, minus 2. So that would be my answer for part A. So we'll come back to that and mark it. It's going straight into finding a line equation. Sorry, not a line equation, a gradient of A to B this time. So you want to use your line equation. You want to use your gradient equation, which is the change in y's divided by change in x's. It doesn't matter which coordinates you use first. It says A to B, so you can use A first and minus the y values from B, sorry, or likewise you could do from B to A. It doesn't matter. Just for convention, I'm going to do from A to B. So my change in y is 3 minus 1, and my change in B is minus 2 minus 4. That's my equation. When I work it out, that will give me 2 over minus 6. You might be tempted to you might be tempted to leave it like that, but remember it says in its simplest form. So that right there means they want you to simplify it to 1 over 3 or minus a third. So that right there is your answer, okay? I'll come back to the marking, but if you had 2 over minus 6, they would only give you the mark for the working out here. Next, it wants to find a line equation, AB. We just found a gradient, so that's going to be very useful. And it wants it in the form of, instead of ax plus by equals c, they have no coefficient on x, so that's saying that you can end up with x by itself. And they've changed the letters or coefficients to q and r, okay? Don't let the different letters phase you, they're just numbers, okay? But this bit here, just x by itself, if you have a number on your x, you might have gone wrong. We've got a gradient, so for part 2, you're going to be using y minus y1 is equal to m times x minus x1. You've got your gradient, so that's equal to minus a third. And likewise, because it's the line A to B, it doesn't matter which one you use. You can use A, you can use B. I'm going to use A, so I've got x minus 2 gives me plus 2, and I've got y minus 3, so y minus 3. Straight away, instead of working with fractions, you could just multiply the whole thing by 3. If you do that, you're going to end up with 3y minus 9 is equal to minus 1 times x plus 2. So that already is quite simple. Expand that bracket out, so you get minus x minus 2. You end up with 3y minus 9 here. Just move everything over. So if you move the x over, it becomes positive, plus 3y. Move the 9 over, so it's going to be plus 9 to both sides. If I plus 9 to both sides, I'm going to get 7. So that there would be my answer. Let's go back and read questions. Even though it says q and r are integers, so my number or coefficient on y, my constant, there's no need to actually say q is equal to 3 and r is equal to 7. You could just leave your answer just like that there. We'll come back to mark that in a bit. Next one then, find an equation of the line passing through C, that's one, that's parallel to A and B. So it's going to be the exact same thing here. So if I work over here, going to be another line equation. So y minus y1 is equal to mx minus x1. Parallel, well, the word parallel should tell you that you need to work with the same gradient, and this is where C is important. You're going to be using the C coordinate instead. So parallel line passing through the coordinate C. So it's going to be x minus 2 and then y minus minus 5 or y plus 5. Once you're there, it doesn't actually tell you what form it wants it in. So it's up to you kinda to decide for yourself. I've been nagging that they'll let you have this as your final answer, but it's probably wise just to expand it just in case. So I will expand it right now. So I've got y is equal to minus a third x minus 2 over 3. Oh, sorry, double negative. So minus minus, that's actually plus. And if I move the 5 over, it's minus 5. But if I want to put over 3 as well, I need to make that 15. So 5 times 3 gives me 15. So my answer, if I were to expand it out, would be minus 13 here. I could times both sides by 3 just to make it look a bit tidier. So it would be 3y is equal to basically minus x minus 13. But I might as well move everything over. So plus x plus 13 is equal to 0. Something like that. But otherwise, yeah, it's completely up to you if you want to leave in this answer or as this answer here. Probably because your previous answer is in ax plus by equal to c or plus c equal to 0. It's probably wiser to go for this answer right here. I'll come and check that in a moment. Part C then, I'll do it here. Remember, when it says a triangle, you've got to try every combination. So AB, BC, and CA. If it says angle like it does here, that's a very good situation. So now, hey, can't rub out. Oh, that's weird. Anyway, when it says angle, it's basically saying the angle between A and B and B to C. So all you need to look for is your gradient for A to B, which you have somewhere around here. Where is it? Part BI minus a third. So all you need now is the angle, or sorry, the gradient for B to C, because what we're going to do is we're going to do this to prove that it's a right angle. So if I quickly do the gradient from B to C, so B to C, change in y is 1 minus minus 5. So 1 minus minus 5 gives me 1 plus 5. And then I've got 4 minus 2, 4 minus 2. Top gives me 6, bottom gives me 2, 3. So now if I do gradient of AB times the gradient of BC, that is equal to minus a third times 3. That does give me minus 1. And that is proof enough. So let's mark this now. Is this grayscale? Not grayscale. Let's have a look. So click on the mark scheme. So there, coordinates 3, 2. Mark is basically either correct or basically both chords correct. Essentially, you could argue it's just a mark per coordinate. So there and there. Preferably, I would probably give working out for the method and one for the answer. But it's always nice to know that they'll give you a mark for each value. If we go back to B, the answer is minus a third. So minus a third. If we go back to the notes, it says having the the gradient as 2/6 implies you've done working out. So that will give you, well, this or that will give you the working out mark or your method mark, but your final mark has to be in this form. Go back. So they've got x plus 3y equals 7. So x plus 3y equals 7, right? So that's one answer. There's actually 2 marks in this. So your other mark is probably, where is it? Yeah, so they give you a method mark for this bit here, which is your line equation, and it says their gradient. So if you got this wrong, you could have error carried forward eventually. But here they've used one coordinate, I think that's A, and here they've used the other coordinate, which is B. So you get 1 mark for the line equation and substituting numbers in. So there are the 2 marks there. So let's go to the next question, the parallel one. Where is it? It's right here. Let's go to the parallel one. They've got their gradient A or B. Again, error carried forward. This is one coordinate. Oh, sorry. This is the C coordinate, of course. They can't use any other coordinate. But here they are letting you have, for stars, you get 1 method mark for substituting numbers in. So I've got 1 mark so far. And they are allowing you to have either that as your final answer. So, where is it? Oh yeah, true. They're allowing that as a final answer. Or in the form of ax plus by equals to, or plus c equals to 0. So they also allowed this as a final answer as well. Seeing as they allowed this as a final answer, they would also have to allow this as a final answer. Even though it's not on the mark scheme, it's still the equation. You've just expanded basically this line to that line there. But seeing as this is before this, they're going to mark you here anyway. So that's always nice to know. And then lastly, part C, find out if it's a right angle. It's got quite a lot of marks. It's got 3 marks here. So your first mark is finding gradient BC. So 1 mark there. The next mark is for, where is it? I suppose it would have to be timesing them out. So, I've made that statement, so I'll probably get a mark there, but I'll be more comfortable about giving all the marks here. So that'll be your second mark, and then your third and final mark, of course, is making that statement. That hurts. I did not make that statement, so I would not get the final mark. So just saying it's equal to -1 is not enough. So I need to say equal to -1. Therefore, A, B, C is a right angle. So I do not get the final mark there. So if we tally it up, it's quite a lot of marks here. So if we go back to red, I got 2 here, 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 all 2s, red. So I've got 8, 10. So I got 10 out of 11 marks. So just be careful. I made a mistake here. I did not make that statement. You need that statement because that is the final mark. So saying that either the products of the gradients or this thing right here is equal to -1, therefore the angle, sorry, I should probably write angle ABC is a right angle. Hope you found it useful.